I will not show you a lot of data today. I started here, as you know, last year and developed this IWM program, Integrated Weed Management Program for Midwest corn and soybean production system. And I'm going to show you what are the current approaches that we are moving forward with, and what are our current as well as future goals for the ISU Weed Science Program with the Department of Agronomy. So I welcome you all today. So for the first slide, if I can transition here. So talking about weeds, as you know, that the annual crop losses caused by the weeds, and this is the data generated by USDA and WSSA Weed Loss Committee. For North America, on an annual basis, the loss in the revenue for corn and soybean is $27 billion and $16 billion respectively. So inadequate weed control technologies can cause definitely a drastic reductions in these two major crops of the US. Here I want to show you some of the historical and the current scenarios, what's going on with regards to weed management practices in US corn and soybean production system. So I'm highlighting here the year of 1996 to the period of 1996 to 2012, as you can see. And on the top, these are the, and across the bottom slides, you see the graphs, you see the various weed management practices over the last, over the period of 1996 to 2012, including scouting of weeds, in corn and soybean, the mowing the field edges, plant densities and planting dates, and all those weed control practices, and the trends over that period of 1996 to 2012. However, I'd like to focus your attention towards the bottom set of the graphs that you see, and I will set up the graph for you first. On the y-axis is the percent of acres planted to corn, which is in blue, and soybeans, which is an orange line. And on the x-axis, you see 1, 2, and 3, and 4, and those are the calendar years, 1996, 2000, 2006, and 2012, respectively. If you look at the trend overall at the bottom left slide, which says on the top of the graph, used herbicide other than glyphosate. So from the period from 1996 to 2006, both in corn and soybean, if you can see my pointer right there on the slide, you see a sharp decline in the use of other herbicide sites of action other than glyphosate, and that decrease in the diversity with regards to the herbicide is more in the soybean compared to the corn, as you see. And similarly, you see the same kind of trend if you move at the bottom slides again towards your right, reduction in the tillage over that duration, and cultivation and other weed control practices. So why this lack of diversity is happening during this time frame? I'm going to answer that question first, because that is very important to understand. And then if you go back to this used herbicides other than glyphosate slide, we see a jump in the use of other herbicides other than glyphosate, especially in the soybean, and I'm going to explain why. So the 1996 is the time, was the year when the glyphosate-resistant or Roundup Ready technology came into the marketplace from Monsanto with the release of glyphosate-resistant corn and soybean. And over that period, 1996 to 2012, you see an increase in the number of acres or percentage of planted acres under corn and soybean, as you can see with the blue line, which is the HT herbicide-tolerant corn, and the red line here, HT soybean, as you can see. And the adoption rate of the glyphosate-tolerant soybean was, of course, definitely more faster as compared to the corn. And you see a concomitant decline in the use of other herbicides with the as indicated by the purple lines. So a lot of acres, more than 95% of the US corn and soybean acres were getting application of glyphosate, and this has definitely was very economical and beneficial, and has led to the rapid adoption of no-till systems in the Roundup Ready or glyphosate-tolerant corn and soybean acres. But with the overuse of glyphosate, this is where we are standing right now. On the y-axis, you see the number of weed species that have developed resistance to glyphosate on a worldwide, on a global scale. There are a total of 43 weed species during the time frame. Again, remember that from 1996 onwards, with the increase in the glyphosate use, there is increase in the selection pressure for the development of these herbicide-resistant weeds, lack of diversity in the weed control program. So right now we are standing in a critical juncture in the weed science community, talking about glyphosate-resistant and other herbicide-resistant weeds, and the predominant and the most troublesome is the palmer amaranth, followed by water hemp, which has become definitely a threat to the conservation tillage, which was, of course, one of the benefits of this technology. And here, I'm trying to answer the second question. If you if I can draw your attention back on the lower right portion, on the graph that has the number 9, which is the site of action of glyphosate, which is the EPSPS synthase inhibitor, as you see on the top. Those are the codes, or in parentheses, those are the WSSA codes for the site of action. And you see on the y-axis, these are the number of herbicide-resistant weed species, as you can see here. So during this time frame, with starting with the first occurrence of glyphosate-resistant weed right here in 2001, which was horseweed or mare's tail, as we all know of, it's pretty common here in Iowa as well. There has been a rise in the number of glyphosate-resistant weeds, as you saw in the previous slide. And then just to control those glyphosate-resistant weeds, there has been a rise in the number of other herbicide sites of action in corn and soybean as well. And that's why during this time frame from 2006 up to 2020, we see a steep increase in the multiple resistance to a lot of these chemistries that are available, as you can see on the top, these modes of action or sites of action of herbicides. Talking about the sites of action, we have a total of 26 herbicide sites of action globally in the marketplace right now. With the discovery starting from 1940, if you remember, was the first herbicide that was discovered in 1940. Right here was 2,4-D. And then with that, there was an era of chemical weed management, and a lot of discovery happened during the time frame of 1940 up to 1980 up to 1990, as you can see. And after that, there has been no new mode of action or new site of action that has been discovered. So, which again, during this time period from 1996 or 1998 up to now, we are seeing more and more herbicide-tolerant trait technologies, how the existing herbicide chemistries are being put on those traits, like starting from glyphosate resistance trait to Liberty Link trait, now 2,4-D tolerant soybean, which is the enlist trait, and the triple stacked Dicamba trait, which is also coming forward for next year. And so definitely with the lack of new effective site of action, and weeds have evolved resistance to 23 out of those 26 known site of action. So definitely we need to think beyond herbicides from a weed management standpoint. So now coming back to the corn and soybean production systems of Iowa and Midwest, these are the three major driver weeds, which are called as giant ragweed, mare's tail or horseweed, and water hemp, which have developed resistance to glyphosate and other site of action of herbicides that you see here. Definitely, water hemp resistance is a major issue for us here in Iowa, corn and soybean, and across the Midwest, because we do have 6 resistant water hemp reported in Illinois and Missouri water hemp populations. And that includes resistance to synthetic auxins, which we have not yet found in Iowa, but has been reported in Illinois. So this is the dynamics of multiple herbicide resistance in water hemp, and how many effective site of action or herbicide groups has been introduced over the period of time, as you see in the black line, And the red line indicates the cumulative resistance in waterhemp over calendar years. As you see that with the total, we have a total of 8 herbicide sites of action that we can use in soybean to control waterhemp. And if you see this number right here, by 2010, waterhemp has developed resistance to almost 6 to 7 of those chemistries already. So after joining in the summer of 2019, I conducted a survey, my program conducted a survey of waterhemp resistance, trying to understand the dynamics of resistance. And we went back to the same georeferenced sites that Mike Owen has used in his survey back in 2012 and 2013. And we went back to those exact same fields and collected samples, trying to understand how the dynamics of resistance has changed over the period of 6 to 7 year gap as a result of the differences in the management practices in corn and soybean in Iowa. So this is the greenhouse screening where we are looking for all those 8 different site of action of herbicides. I'm not showing a lot of data here from these experiments, but this is PPO resistant cobra waterhemp population. As you can see on the left hand side is the untreated plants. 1x represents the field use rate of cobra or the PPO inhibitor, and 4x is the ultra high rate. And you can still see how those waterhemp plants are surviving 4 times the field use rate or the 4 times the recommended use rate. This is Callisto. You all know about this. We have used this chemistry a long time in corn, HPPD chemistry, but waterhemp has evolved resistance to this, as you can see in this picture. We wanted to know what's the response of the Iowa waterhemp populations to 2,4-D, since 2,4-D will be a trait that has come into the marketplace as an enlist trait in corn as well as in enlist soybean, triple stacked. So we definitely want to see, okay, we are using these new traits to control glyphosate and some other resistant weeds, but what's the response of our current waterhemp population? So based on some of the control failures that the growers experienced last year, we went to some of those fields and collected seed samples. And yes, we saw some issues here with our screening program, that even with the 1x rate, you can see that waterhemp plant is surviving and producing a seed head right here. If you can see my cursor on the slide. This is the response of one of the Iowa waterhemp populations to Dicamba. As you can see here, right here, the plants are pretty well twisted and curled at the field use rate of Dicamba, which is Xtend recommended for Xtend beans. But even those plants are small, they are producing seeds. So in order to do some more work looking at 2,4-D and Dicamba survivors, what we did is in the agronomy farm right now, agronomy greenhouse, we have 3 of those greenhouse rooms totally booked for this herbicide screening work with those 250 populations. And as waterhemp is a dioecious, there is a male and a female plant in each of those pots and kept under pollen isolation conditions so that we get the F1 generation of seeds to conduct entire dose response and to understand the mechanism of resistance if we find there is resistance. This is the status of the herbicide resistant waterhemp in Iowa. I don't want to go into the whole details of this, but on the y-axis, this is the survival frequency. So out of the whatever populations we have screened, up to 75 to 80 populations, resistance to pursuit, atrazine, and glyphosate Roundup. I mean, this is 97 to 100% of those populations right now. So with PPO inhibitors, which is Cobra and Callisto HPPD, we are seeing somewhere in the range of 20 to 33% survivors or survival frequency to the 4x rate. So definitely these are resistant populations. They survived ultra high rate. With Enlist 1 and Xtend Max, which is 2,4-D and Dicamba, again, those populations were tested at 1x rate. We see 30 to 33% of survival frequency in those out of those 80 populations that we have screened so far. So coming to this integrated weed management concept, I think herbicide resistance is a global problem, more of a problem in the US corn and soybean production systems because of the heavy reliance on herbicides and lack of diversity that I showed earlier in my previous slides. So it is a complex problem, and there are socioeconomic consequences of this, and from, just from an extension standpoint, I would say the solutions cannot be simple either, and that's what I tell my growers, that the solutions are not definitely for short term, but we need to think out of the box and develop an integrated approach. So what we are doing at Iowa State University Weed Science program is this, developing some of those IWM tools and practices. So the first is how we are going to efficiently manage water hemp more aggressively in corn. So we initiated a study for 2 years at the ISU Curtis and Brunner farm back in 2019, and this is the second year. The first year was in corn, as you see on the left picture, and the 2020 was soybean. So on the left two pictures represent that a low or a less aggressive weed management program which was implemented in corn, and you can see the consequences in the following season in 2020 with a lot of water hemp in between the soybean rows. However, if you come to the right, in 2019, we went with the full aggressive weed management program and also removed the survivors from those plots to prevent any seed additions. We see a relatively clean field in 2020 in the following soybean crop. So definitely it is more important to understand that although corn is more competitive to weeds for water hemp for here, but definitely we need to think about more aggressive weed management so that we reduce the seed bank. And in this, I'm not showing you the data. In this case, we reduced the seed bank to 75% in the following soybean crop. The second strategy, which I can refer to as the early weed control tactic, is the use of cereal rye as a cover crop, which is well adopted in our region. So one of the major challenges with cereal rye is, from a weed management standpoint, is the biomass. So how we can optimize the termination timing of cereal rye to maximize the biomass production. That is the biggest challenge, because when we are terminating the cereal rye as 7 to 10 days before soybean planting, the biomass is not enough to cause practical sense and to invest that $30 an acre investment in if you are looking from a weed management standpoint. So here are the objectives of the cereal rye, which I think is important to understand. Is the first objective is to reduce the weed population density and the size of the weeds at the time of application, and giving us more flexibility in, and timing for application of our post-herbicide programs, and overall reducing the herbicide inputs and selection pressure. And I think, again, you will not see the immediate effect of this system, but overall the goal is long-term reduction in the weed seed bank. Again, this is the trials that we initiated back in 2019. On your left, you see the soybean without cereal rye cover crop at Curtis Farm this year, and this is soybean with cereal rye cover crop. I mean, I don't have to explain this slide. You can see the difference. The cereal rye was planted on October 10 of 2019 last year. It was terminated May 15 of this year, and the soybean was planted right on top of the cereal rye, which is the plant green concept, on the same date, and was terminated with glyphosate. So more the biomass, more the weed suppression that we are going to get. This is, again, I'm showing you some of the data here. We really wanted to quantify the effect of cereal rye termination timing, and this is when cereal rye was terminated at anthesis. This is the 4,600 pounds per acre of biomass, because this is one of the grower questions: how much biomass, or what should be the optimum timing of cereal rye? And across our 4 studies, I mean, those big trials that we did this year, and we are going to repeat some of those because all those are long-term trials. Those 4,600 pounds per acre average was the optimum biomass that you see here, causing the difference between no cover crop versus cereal rye cover crop. So did we achieve our goal? I think we did. There was a reduction of water hemp cumulative emergence by 30%. And as you can see with those in the right-hand side with the picture, those water hemp plants which are in between the soybean rows were much smaller in size and had less biomass, which was overall reduction of 75%. So I think And also we took seed production data or the seed input data, and there was a reduction in the seed inputs in the presence of cereal rye cover crop. So overall, we will be achieving the efficacy of our post program, because now on the right hand side picture, when you are applying a post herbicide program, you have less density of weeds, you have smaller size weeds, definitely more effective weed management program as compared to the scenario where there is no cereal rye on the left hand side. The second strategy, we are looking at how we can reduce the soybean row spacing to suppress water hemp and other weeds in the field. Because the advantage is we all know that with 15-inch row spacing, there is an early canopy development. And the picture clearly taken from ISU Research Farms for these trials which were initiated last year. You can see the difference in the weed pressure in 30-inch row versus 15-inch row spacing. There was an overall of 15% reduction in water hemp density between the two row spacings, and a 50% reduction in the growth and size of water hemp plants. Again, we are achieving the goal of reducing the seed bank inputs. These are some of the UAV-based imaging pictures of those field plots that we took. You can see some of the clear differences in on the left-hand side, no cover crop, just the effect of row spacing, 30-inch versus 15-inch right here, and then cereal rye versus no cereal rye. So, and this is the integrated program right here at the bottom right. A cereal rye with reduced row spacing, you can visually see the differences right there. So in this cover crop by soybean row spacing interaction study, which we have started last year at the ISU Research Farms, and testing this plant green concept, as you can see in this picture, one of my grad students terminating the cereal rye, and right at this stage, we planted our soybeans. And of course, we are taking yield data, and so far it looks good. So just the data here, I have water hemp densities in per square feet. I want to show that with integration of this cover crop and 15-inch soybean, as you can see on the extreme right, versus the standard practice where we are not using a cereal rye cover crop and the soybean is grown in 30 inches, there is a 50% reduction in the water hemp density or cumulative emergence in between those two strategies. And as I said, like individually, these strategies, these are multi-tactic tools that complement our herbicide program. But of course, we know at this point that none of these strategies are going to be standalone practice. The last thing which I wanted to talk a little bit about today is what else we can do to, from a non-chemical weed management standpoint. Can we capture the weed seeds at harvest? And this is this is a picture here. As you can see, everything that is coming out of the combine is in the form of a straw and chaff, and the weed seeds are in the chaff fraction of this straw plus chaff that exits out of the combine and thrown at the back of your combine. So the idea here is to put a baffle which is right here to separate the straw from the chaff, understanding that the weed seeds are within the chaff and what we can do about this. This is a picture taken by Bob Hasler of the weed seeds that were blown out of the back of the combine, and a pretty rapid mechanism of spread of herbicide resistance across the field and within the field, as you can imagine. And how we can minimize the spread of resistance. So this is the concept of chaff lining, which was developed and adopted by 70% of the growers in Western Australia facing with herbicide resistance, more so than us here in the US. And their biggest problem is the ryegrass. So this is the chaff line where they have put a chute behind the back of the combine where all the straw is coming out through the chopper, but we are concentrating this chaff line in narrow windrows, which is 12 to 15 inch. And this is a wheat stubble in Western Australia. And as you can see how within that 30 or 35 foot header, we are concentrating all the weed seeds. Instead of spreading it out at the back of the combine, we are spreading it in those narrow rows behind the combine. This is how it will look like in the next season, that you will have concentrated herbicide resistant, multiple resistant rigid ryegrass in those narrow windrows, which will be much easier to manage using some of these targeted weed control strategies, high rate of herbicides, shielded sprayer, or even precision application technologies. So we took that concept and we wanted to see whether we can apply this in Iowa corn and soybean production system. So this is Avery Bennett, one of my grad students, who is trying to capture the waterhemp seed retention at the time of soybean harvest. How much of that waterhemp plant is retaining the seeds at the time of soybean harvest, so that we can capture those seeds more efficiently. This is the data right here, percent seed retention of waterhemp on the y-axis, which is indicated by this blue line, and the green line shows the percent soybean harvested on a 5-year average. And as we see from October 1 to October 15, that's the time phase where we are harvesting more and more of the acres of soybean over the last 5 years. And this is the waterhemp seed retention. As you can see, it ranging from all the way in early harvest scenario from 98% and up to 80%. So even in the late harvest scenario, we can capture 80% of those seeds and prevent weed seed bank additions. So so we started this research last year. We collected soybean chaff. It was a pretty difficult process for us, but somehow we were able to do this with the combine that at the Curtis farm. And we calculated the chaff to grain ratio, which was 6:1, 6 tons of soybean chaff per 1 ton of soybean grain. And we did it at multiple locations to get to that ratio. So greater the amount of soybean yield, more amount of chaff you're going to get. So based on the 6:1 ratio, we calculated the amount of chaff needed for different soybean yield potential scenarios. For example, here is the low grain yield, which in bushels per acre is 40 bushel soybean. The medium is the 57 to 60 bushel soybean, and the high yield is the 70 bushel soybean. So we calculate the relative amounts of chaff that is equivalent to those 40, 57, and 70 bushel soybean, as you can see. And then we conducted some greenhouse experiment to see the effect of that chaff, soybean chaff. On the right-hand side, you see no chaff, whereas increasing amounts of chaff for all the way from 396 kgs per hectare, which is the 40 bushel per acre soybean, up to 70 bushel per acre soybean chaff that you see here. You see, if you pay close attention, in the no chaff, a lot of waterhemp again in those parts. The waterhemp seeds were mixed with the chaff in all the 4 situations. You can see a good amount of waterhemp even at the 396 kg per hectare of chaff. But as you move with the amount of chaff as goes up, there was definitely a reduction in the emergence. And also I'm showing the data here as a percent of the emerged waterhemp over the 45-day time period. Definitely there was a 70% reduction. As you can see, the green line is the no chaff, where the seeds are lying on the bare soil surface, versus the seeds which are somehow buried in that chaff. And we did for other weed species apart from waterhemp. So depending on the size of the weed species, I mean, basically this chaff is acting as a mulch, as we do in the gardens. So you can see a clear mulch effect here. This is velvet leaf here at the left with no residue, versus with increasing amounts of residue, you see a suppression. Not so much as you'd expect for waterhemp, but definitely it is applicable to other weed species. Can we take this technology to the field? To do that, we collaborated with a company in Western Australia, and this shipping came day before yesterday. With this chaff lining chute, as you are seeing in the picture, which is going to be attached to a John Deere S-Series and STS Series combine. So Boiler Making Service, that's the company that makes these chutes and the baffle, the chute and the baffle that will go behind the combine. Most inexpensive method of harvest weed seed control. It cost us around $5,000 for each of these units. Pretty easy to install, no major modifications to the combine. So we are actually this afternoon we will be done with setting up this. shoot behind the combine, and tomorrow we are going to run this at the time of soybean harvest. Some of the data we wanted to collect out in the field is how this chaff lining is affecting the weed seed viability, the emergence, and the interaction with the herbicides. So this is the design of the study, which I don't want to go into much detail, but we will initiate. And this equipment is the first unit that, that has come to the United States. We also have this weed seed destructor now, which we got from Redekop, and this project was funded as a part of the GROW team from USDA area-wide project, and we have installed this in one of the grower combines, which is a John Deere 7680 combine. On the left, you see without the seed destructor, and on the right-hand side, if you see at the bottom, that's where the seed destructor is, right here. So these are my grad students who have worked pretty hard to get this done since it's been less than 2 weeks that we received this, and it took us a lot of time to put this together. But I'd like to mention this Redekop seed destructor, which you see here, is going to will be an add-on feature with the John Deere combines once we are done with our testing as a proof of concept. So we will be testing this unit first time in the US, and there are multiple locations, including Arkansas, University of Arkansas, testing this with some of the experiments that we will be starting actually starting tomorrow. Why we think this seed destructor is going to work? So you see at the bottom is the picture of the high impact mill. So inside this destructor, so from the chopper, all the straw fraction will come out of the combine, and at the bottom, instead of the chute, here we have this seed destructor and the high impact mill, where all the weed seeds will be pulverized. They will be milled or crushed. So and that's how we will render those weed seeds as non-viable. So this is some of the data that was collected based on the prototype they had in Western Australia, where we sent some of the weed seed samples to them to test this concept. For giant ragweed, palmer amaranth, waterhemp, and other weed species, the percent seed destruction as the seed goes through this high impact mill is close to is more than 90% up to 100%. So none of these technologies are going to be standalone practice, as I said here, and we are looking at the long-term benefits of these multi-tactic tools to achieve a more resilient weed management programs in our corn and soybean production systems. So here I'm showing the data from 2001 to 2016 from Western Australia with annual ryegrass density in plants per meter square, and the green line represents the herbicide system, the conventional weed control program, plus a harvest weed seed control method, which was chaff lining, since it has been very economical, because there is an investment of less than $5,000 right there. And the red line is just the use of single or multiple herbicides as the means of weed control in that particular field over the 15-year period. So as you can see here, the initial decline in the ryegrass populations from 2001 to 2008 was as a result of the herbicide, and maybe it was glyphosate. For example, just an example, it was glyphosate which was effective for so many years. And as you can see, this red line, it never tapers down. You can see still the plants are in this 5 to 10 density is still in the 5 to 10 plants per meter square. If you calculate on an acre basis, it's a significant number. However, when we are integrating in harvest weed seed control method or any other tactic, within that, starting from 2008, you see the green line kind of tapping down, and we see achieving almost less than 5 or less than 2 plants per meter square. So that's actually what we are trying to emphasize is. So with all these multi-tactic tools, we are aiming for a long-term, there are long-term benefits, and that's what our growers need to realize, and how we can, to improve the adoption of these multi-tactic tools. One of the research that we are focusing also is using some of these precision ag platforms for weed management, use of hyperspectral imaging and smart algorithms using machine learning to detect herbicide-resistant weeds in crop. And this is the figure, the slide here of the soybean field in central Iowa, where the drone was flown, and you can see those waterhemp patches in that imaging picture. So this is again a collaborative work between the ISU Weed Science Program and some of the my collaborators from Montana State University, that we did some of the pioneer work in this area of developing some prescriptive weed maps for precision weed management and application of robotics in the future. Talking about the collaborations, we are a part of this GROW team, which is a nationwide getting rid of weeds. That's what the GROW means, through integrated weed management, in developing this cost-effective and sustainable programs across the United States. This GROW IWM USDA area-wide project has funded a total of $3.5 million over the last 3 years. And the funding has gone to 15 states in the US. And as you can see, Iowa State University since last year is a part of this GROW team, which has multiple partners, including industry and as well as the public agencies. The GROW team comprises weed scientists, sociologists, and economists from all these 15 states. So I'd like to acknowledge here that from the USDA area-wide project, that was the funding that funded us to get the weed seed destructor, Redekop weed seed destructor that we have here today at Iowa State. We are also collaborating with the Iowa Soybean Association on-farm network for adoption of some of these improved systems. For example, on the top, you see the Rye Cover Crop, soybean planted in narrow rows with and without the seed destructor versus the normal system where the standard practice of with the no seed destructor. So these will be long-term trials which we started working starting this year with the Iowa on-farm network, as well as we are starting this research also with the practical farmers of Iowa. So these are the no cover crop strips and the cover crop strips, and again multi-tactic approach here. The plot size is 1 round of the harvester by the length of the field, as you see here. So these are the multi-state collaborations which we have right now, and the various sources of funding. When I came here last year, there was some amount of USDA NEPA project which I moved here at Iowa State. We received this week, basically a couple of days back, we received a notice of funding from USDA NRCS CIG Conservation Innovation Grants, which is again a multi-state $2.1 million that was funded to do all this work. United Soybean Board, Iowa Soybean Association, North Central Soybean Research Promotion has also funded Iowa State Weed Science Program over last year and this year specifically. I would also like to mention the acknowledge private industry, because we are running the statewide herbicide evaluation and demonstration program here at Iowa State, and looking at some of these herbicide technologies that we are going to see in the near future, or are evaluating those. For example, right here, the picture is the low tunnel studies that we are doing for mitigating Dicamba drift and volatility. And this goes back to the previous presenter about some of the drift issues, the monarch butterflies, and the natural habitat protection of some of those species. So definitely this work is also ongoing, and a picture from Central Iowa plots that we had this year. I'd like to thank, this is my last slide, and I would like to definitely thank my graduate students and my team. From the left, this is in the soybean field, is Alexis Meadows. She joined my program from Illinois summer of this year. On her right is Ryan, who joined the program last year. He's the guy who's working on this herbicide resistance screening work. Avery Bennett, he's working on the chaff lining project. Ram, you might have seen him with the seminars. He moved to Iowa State. He's a PhD program with me from Montana State. And Steve Durden, who is again my graduate student working on cover crop termination timing and that sort of work. Also like to acknowledge here, Austin Skletch will be joining the ISU Weed Science program starting spring of 2021. And thanks to you all probably know these two guys on the right, Damien and Alex, doing a great job, outstanding job with the Weed Science program. And thanks a lot to all these folks. With that, I would like to answer questions.
Thank you, Dr. Shah. That was a great presentation. I believe that that's a very, very useful project because as you mentioned that this is like a global problem.
Thank you, appreciate it.
Dr. Shah can get your questions, everybody. Feel free to unmute yourself or put your questions in the chat box.
So Prashant, this is Ryan Hornbuckle. Can you hear me?
Yes, I can hear you, Ryan.
Okay, so you mentioned the three different techniques, the aggressive weed control, the use of cover crops, and then the row spacing. Can you, I didn't understand what is meant by aggressive weed control. Can you be more specific about what an aggressive weed control would be in that first example?
Yeah, so the aggressive weed control, Brian, to answer the question, what would be the aggressive versus the marginal weed control program? So in the corn phase, we basically, our aggressive program was multiple herbicide sites of action with a pre and a post herbicide, using premixes and multiple sites of action. At the same time, with the aggressive program, any survivors of water hemp in those corn plots last year, they were we prevent any kind of seed production. So it was kind of like a harvest weed seed control simulated situation. In the marginal program, it was just a sole reliance on glyphosate only system with a weak pre-emergence herbicide program. So really the idea was what is the importance of developing an effective weed management program in corn, because a lot of times our growers have that impression that corn is a competitive crop, so we can still go with a less aggressive weed control program, and that definitely is not recommended, because you saw just because of the amount of weed pressure that you're getting in your next year's soybean, there is a huge difference. Does that answer your question, Brian?
Any other question to Dr. Shah?
Hello.
Hi.
Oh, I have a question. When they concentrate the seeds in the a single band, can you elaborate on what actually farmers do on those central band with lots of seeds of weeds?
Yeah, that's a good question. So we don't know I don't have a perfect answer, because this will be the first year where we are going to actually test that concept. Earlier in Western Australia, it was in wheat. So as I showed in my greenhouse trials, we would expect a reduction in the emergence of the weeds in those narrow strips as a result of the residue, as a result of the soybean chaff, because of the burial of those weed seeds in that chaff during the overwintering period with the amount of moisture and the snow on the ground. So that is one. The second is we will be putting some temperature and moisture sensors in those plots with chaff and without chaff, which is basically the bare ground without chaff. So that the idea is, are we impacting the micro environment? So that are we promoting more seed decay in those chaff versus no chaff. So to answer your question, yes, I think our hypothesis is we will see reduction in the emergence next year within that chaff layer. At the same time, it will be much easier for us instead to manage that chaff with a shielded sprayer application or any technology in those narrow bands compared to the entire field.
Yeah, so that's great to know. So I was thinking that over 1 year, narrow bands of heavy weeds is there. If it's better to have a better control. Otherwise, next year the band will shift to the different place in the field, and then over many years you might be spreading that like even out. So having a good control right after you apply, have this application it's kind of critical, right, for the over long term.
I absolutely agree with you, Zen.
Yeah.
That's definitely that's the target. And what kind of strategies besides herbicides we can develop? That is again one of our approach. That can we do targeted tillage in those narrow bands? So yes, so those are some of the definitely some of the questions that we have. We don't know the answer.
Do you know who actually started thinking this way, or was farmers start doing on this thing? This idea, having them concentrated is really nice, right? Really
Yes.
great, brilliant idea.
It's kind of like a narrow window burning that they were doing in Western Australia, but again with the EPA regulations and all those concerns. I think,
Okay. Yeah, there's other stories.
So
Okay.
they tried. So they were concentrating these. They were making these narrow bands or chaff lines, and then they were also using narrow windrow burning.
Okay. That's
yes,
good.
which will destroy those weed seeds. But again, for the U.S. production system, in majority of the years, or from an EPA standpoint, I think burning is definitely not an option for us. So we definitely have to figure out alternatives.
Okay, thank you.
Thank you. Thanks.
We got another question.
I'd like to add one thing on that. The question here,
Okay.
the guy asked question mentioned that maybe that chaff line would be spread out through the field at different locations after each harvest. The goal is that you apply that chaff line on top of that same chaff line prior, year after year. So you're going to use a traffic control farming method so that you're not spreading that chaff line, that high density weed material throughout your whole field. You'll be using the same line for pretty much your whole farming system.
Good point. Yeah.
Thank you.
Can
Thank
I
you,
also follow up on that? Prashant, why is burning not an acceptable thing to do here in the United States?
I mean, we can do this. I mean, people have tried this narrow windrow burning, but again, the amount of residue that we will have, it all depends on what amount of moisture we have on the ground and the amount of residue. So,
Yeah, we got another question, Dr. Jha, from Dear Daniel. Daniel asks, are there other cover crops that you are using in your studies besides cereal rye?
yeah, I think that's an excellent question. So, when we talk about other cover crops, yes, in each of these experiments, we are not using any other cover crop other than cereal rye. But some of the recent work that has been done shows that cereal rye is the best cover crop with regards to, first of all, it is one of the winter seeded or fall seeded cover crop which is going to survive as compared to some of the brassicas or legume cover crops. The second is the amount of biomass that you're getting from a grass cover crop that will make practical sense, that physical barrier for weed management or suppressing the weed emergence. From that point, cereal rye is the best choice. So to answer your question, no, we have not tried other cover crops here, but I have done work back in Clemson and South Carolina looking at brassica cover crops, and they're exploiting their allelopathic potential. But again, those are more well suited for the southern climate. But when we talk about the northern climate, I think we are pretty much restricted in terms of what options we have. At the same time, delaying the termination timing and some of the issues with the short growing season of soybean here in the upper Midwest is again some of the considerations. So one of the research that I was also involved with is when you from a weed management standpoint, what they have found is if you are using a cereal rye cover crop monoculture, it is more effective as compared to mixed culture of legumes or brassicas from a weed suppression standpoint. So we definitely want to use this as a part of our toolbox, and I think the growers are more ready to adopt cereal rye. So we wanted to fine-tune the system.
Any more questions to Dr. Jha?
Yeah, 2
Okay.
minutes remaining. 2 minutes remaining. I can take 2 more questions.
Okay. Yeah, looks like no more question. I want to finish this meeting. Great meeting. Thank you so much, Dr. Jha. It was a great presentation and research ideas. Next week, we're going to be having Chris Patricola, and he's going to be talking about influences on tropical cyclones, and we are looking forward to it. Thank you so much for attending today. Have a great rest of your day. Thank you.
Thank you.
Thank you, Dr. Jha, again.
Thank you.